All right, in this video, I'm going to go through the two practice problems, and we're going to start with sketch the graph of f of x is equal to 1/5 x. Identify the key characteristics listed. Make a table if you need to. Now, what it means to make a table if you need to, I'll go ahead and make a table. If you're not sure what 1/5 to the x looks like, then make a quick table of values. All right, so here's x, here's f of x, better known as y. All right, pick some strategic x values. So let's say -2, -1, 0, 1, and 2. All right, pretty simple stuff. Now, the one thing you gotta be careful about is these negatives. So this is gonna be 1/5 to the -2. Now, 1/5 to the -2 is really equal to, and it's going to look a little weird, but it's really equal to 5 squared. Now, you might be asking yourself, what just happened? Well, here's what happened. The negative means I've got to flip the fraction over. So 1/5 flipped over becomes 5. And so then the negative is gone, and all that's left is 5 squared. So when x is equal to -2, 1/5 to the -2 is actually 25. All right. And then if we look at 1/5 to the -1, this is really the same thing as 5 to the first. So that's just 5. Then I've got 1/5 to the 0, which is 1. I've got 1, that's supposed to be a 5, 1/5 to the first, which is 1/5. Which would also be, what is that, 0.2, I think? Yeah, it's 0.2. Had to think about it in my head. And then 1/5 squared is 1/25, which is 0.04. Yeah, I'm slow on that one because I'm trying to make sure I'm doing it in my head, and I'm pretty sure that's correct. Now, whether or not I know the exact values for the decimals or things like that, here's what I notice. As I have larger negative numbers, -2, I've got this huge f of x value of 25. When I have a larger x value that's positive 2, I've got this really teeny tiny decimal. So basically what this tells me is this graph, now this is a sketch, so I don't have to be perfect about it, but this is exponential decay. All right. Now, one of the things I could look at, okay, and I'm going to actually go down to part G here, explain if this is an example of growth or decay. Well, it's decay. All right. And the explanation could be something as simple as, well, when I graphed it, it's decreasing. I would actually like you to know whether it's exponential growth or decay based off of simply the equation. And this piece of the equation, this b value of 1/5, so it's decay because the b value is between 0 and 1. All right. So if your b value is between 0 and 1, you have some kind of a decay function. Now, whether it's a really strong decay function or not, that's up to the problem. All right, let's hit those other key characteristics. So domain, all possible x values are fine. Range is going to be from 0 to infinity. Your asymptote is going to be y equals 0. Now, that y equals 0 is this horizontal line here. You can approach it, but you're never going to touch it or cross it for the problem. All right, so that's that asymptote. Intercepts. Now, you don't have an x-intercept because, well, you can't cross or touch that asymptote, which is the x-axis. You do, however, have an intercept right here, and I'm using the table of values here of 0, 1, which is this point right here on the y-axis. So the intercept is 0, 1. End behavior. Now I'm going to zoom in just a little bit so I have a little bit better spacing here. So as x approaches infinity, so as x is moving to the left, infinity is to the right, sorry. As x is moving to the right, what's happening to my blue curve? Well, what's the function name? F of x. All right, so f of x is approaching 0. And then as x approaches negative infinity, so this is going to be moving to the left. This is actually to the left now. So moving to the left, what's happening to our function? Well, it's increasing. It is increasing, and it is approaching infinity. All right. Interval of increase or decrease. Since this is exponential decay, it is decrease, all right? And it's constant decrease over the entirety of the domain. All right, so that's problem number 1 of all of its bits, parts, and pieces. All right, let me go ahead and slide on down to problem number 2. All right. Sketch the graph of f of x equals 7 to the x and identify the characteristics listed. Make a table if you need to. Now, this one I'm going to do just by my brain, and I'm actually going to do things completely out of order. All right. So the first thing I'm going to do is figure out, well, my b value is 7. If my b value is 7, that means this is an example of growth. So it's growth. Whoops, I'm apparently trying to write the at the end of that word there. All right, it's growth because apparently I can't spell tonight. All right, because b is greater than 1. Now, I know it's growth, and if I know it's growth, I then know what the graph kind of looks like, because I know growth is an increasing function. And this is just, wow, that's horrible. Hold on. My iPad shifted as I was doing that. Yeah, that's what I'll blame it on the iPad. All right, there we go. It's a sketch. I'll work with it. So I know that a growth function is increasing over the course of the entire graph. So I'm actually going to go ahead and answer part F here. Part F asks, is it an interval of increase or decrease? Well, it's an increase. All right. And it's an increase across the entire domain. Now, domain here, I haven't written it, but I know is all possible x values are fine, which is negative infinity to infinity. So I'm going to go ahead and fill in my domain, right? Negative infinity to infinity. Now, whether you're talking about growth or decay, unless your graph has some kind of a reflection to it, the range is going to be the same. So this is going to be from 0 to... I can't draw infinities tonight. There we go. 0 to infinity. The asymptote, we still have this horizontal line here that the graph is going to approach, but not touch, all right? Or definitely not cross it. So asymptote here is going to be y equals 0. Intercept, again, no x-intercept, but we do have this point right here, which would be when x is equal to 0. So if I take 7 to the 0, I'm going to get 1, which means I have an intercept at 0, 1, right? That's my x value with my y value. And the only thing I've got to figure out now is my end behavior. So as x approaches infinity, f of x is approaching also infinity. So as we move to the right, this graph is going up, right? It's approaching infinity. And then as x approaches negative infinity, f of x approaches 0. So as we move to the left, the graph is getting progressively closer and closer to this asymptote, which has a y value of 0. All right, so that's the 2 practice problems. Let me know if you have any questions or concerns on exponential growth, exponential decay, or any of the key characteristics of them.